Okay, so example number 2, we're going to solve a system of quadratic equations algebraically. We're going to use the elimination method, which simply means that we want to either eliminate the y's, okay, or the x's, but it's going to make more sense with this to eliminate the y's. Okay. So the first thing you want to do is to align your similar terms. So notice that we have one equation equal to 0 and the other equal to 4. What I'm going to do is make them both equal to 0, so I'm going to move that one over. And actually, let's call this equation 1 and this equation 2. So I'm going to rewrite equation 2 so it reads 6x squared plus 4x minus y minus 4 equals 0. And then what I want to do with equation 1, okay, I notice that my y's both share the same sign. I'd like them to have opposite signs because I want to add instead of subtract. So that means I want to take this equation, number 1, and I want to multiply it by -1, okay. When I do that, when I go -1 times -1, I'm going to get positive y, and that will give me the opposite signs that I want. So that's going to give me -3x squared plus x plus y plus 2 equals 0. And now you can see that my y's have opposite signs, so I am going to add. And so 6x squared minus 3x squared is 3x squared. 4x plus x is 5x. -y plus y is 0. And -4 plus 2 is -2, and that's equal to 0. Okay, and so now I have a quadratic equal to 0, so I can solve. And I'm going to solve by factoring. Alright, so let's put our organizer over here. My factors of 3 are 3 and 1. And my factors of 2 are 2 and 1. And I want to get positive 5x and -2. Okay, so I want it to add up to 5x. Now this one's kind of deceiving if I set up my organizer like this, because I'm going to go 3 times 1 is 3. 1 times 2 is 2, and you're going to say, oh wow, this works because 2 plus 3 is 5x, except that positive, and that would make both of these positive, right? Except that positive 2 times positive 1 doesn't give me -2, so that's not really going to work. Okay, so I'm going to switch my 1 and my 2. Alright, I want to get 5. So 3 times 2 is 6, and 1 times 1 is 1. And that will give me 5 too, right? As long as my 6 is positive and my 1 is negative. So this is going to be minus, and this is going to be plus. And just remember, this is one bracket, and this is your second bracket. So you're going to have 3x minus 1 in one bracket, and x plus 2 in the second. And so when I solve for x, this is going to be 3x minus 1 equals 0, so 3x equals 1, so x equals 1 over 3. And this one will give me x equals -2. Okay, so I've got two solutions for x, which means I'm going to have 2 points of intersection, so I want to find out what y is when x is 1/3 and what y is when x is -2. Okay, so when x is equal to 1 over 3. So let's substitute that into either one of these two equations. I'm probably going to do it in the second one because I have less coefficients on my variables. So I'm going to go 3 times 1 over 3 squared minus 1 over 3 minus y minus 2 equals 0. And 1 over 3 squared is 1 over 3 times 1 over 3, which is 1 over 9, minus 1 over 3, minus y minus 2. Okay, this gives me 3 over 9. And 3 over 9 is the same thing as 1 over 3. And look at that. 1/3 minus 1/3 is 0. So that leaves me with negative y minus 2 equals 0. And so I get that negative 2 is equal to y. And so one point of intersection is when x is 1/3 and y is negative 2. Okay, my second point of intersection is when x equals negative 2. I'll plug it into the same equation. So I'm going to go 3 times 2 squared minus negative 2 minus y minus 2 equals 0. 2 squared is 4. 4 times 3 is 12. Minus negative 2 is plus 2. And 12 plus 2 is 14, minus 2 is 12. So I have 12 minus y equals 0, and so 12 is equal to y. And so my second point of intersection is when x is negative 2 and y is 12. So the solutions are 1/3 negative 2 and negative 2 and 12. Now, can the above system also be solved using substitution? And the answer, of course, is yes. Okay. So let's take a look. We've got 3x squared minus x minus y minus 2 equals 0. And you have 6x squared plus 4x minus y. And why don't we just bring the 4 over again? So minus 4 equals 0. Okay, now if we want to use substitution, what we will want to do is make both of these equal to y. Okay, so that will simply mean taking the y's and just moving them over to the right hand side of the equation. So I would get for the first equation 3x squared minus x minus 2 equals y. And the second equation would be 6x squared plus 4x minus 4 equals y. And now I want to equate, I think we said we equate our y's, right? Yeah. Okay, so I'm going to have 3x squared minus x minus 2 equal to 6x squared plus 4x minus 4. We have a quadratic, so let's make everything equal to 0. So we bring the 3x squared over, it becomes negative. So 6x squared minus 3x squared is 3x squared. Bring the negative x over, it becomes positive. So 4x plus x is 5x. Bring the negative 2 over, it becomes positive, and negative 4 plus 2 is negative 2. And take a look. This equation that we have right here is the same as this equation that we have up here. Okay, and so as you can see, we can just continue from where we left off, or so we can continue from this point, okay, right here, down here. Okay, and that will end this discussion.